Okay, so volume, as it says here, looks at the space inside a 3D solid. So when we're finding volumes, the units that you're going to use always are units cubed, so they've got the power of 3. Now remember, the cube doesn't affect the value, it's just the unit. Okay? Right, so the most common solids to find the volume of are cubes and cuboids. Now we know that a cube has length, all of these side lengths are the same, so we've labelled them all x. To find the volume, you're going to take one of these vertices. So I'm going to pretend that this green vertex here, and I would multiply the 3 measurements that meet at that point. Now, because they're all length x, the volume would be x multiplied by x multiplied by x, which we would usually write as x cubed. So this here, I've got a volume of this cube. I know that the side length is 5, so I would calculate 5 multiplied by 5 multiplied by 5, or 5 cubed. Okay, both of those are equal to each other, and we would get the answer 125. Sorry, the calculator's not working on here, so that's centimeters cubed. Volume of a cuboid. So the difference between a cube and a cuboid is that a cuboid has different lengths, so they're not all the same. So we would call these the length, the height, the width. Now obviously, depending on how it's standing, the height could be considered as the length, depending if you turn it round. The important thing here when you're finding the volume is, again, to focus on one of these vertices. We will need to multiply the numbers that meet, or the lengths of the sides that meet at that vertex to find the volume. So in this case, I've called them H, L, and W, so I would multiply those numbers together. So for this question here, if I chose this vertex, whilst they've labelled this length as 6, I know that this length is obviously also 6. So I've got 6 multiplied by 5 multiplied by 2. Calculate that. So that's 6 multiplied by 5 is 30, multiplied by 2 is 60. And again, the units are cubed. Now, these two are special prisms. They're a cube and a cuboid. We have other prisms, and a prism is where we have the same shaped face at both ends of a solid shape. So here it could be any shape at all. As long as this shape is the same as the one that would be at the end, it's classed as a prism. To find the volume of that prism, it's the area of this end face, or the cross section, multiplied by the distance between them. Okay, and you get given this in any exam that you do, so you don't have to learn it. So it's the area of this cross-section multiplied by the distance between those two faces. For a triangular prism, the most common triangular prism that we've probably seen is a Toblerone box. Essentially, a triangular prism will have a triangle at the end, and we can see that this one runs all the way through. So we need to remember how to find the area of a triangle. It's area, which is base multiplied by height divided by 2. Now remember, this height here has to be its perpendicular height. Perpendicular. So that means that the height has to meet the base at 90 degrees. To find that volume, you've then got the area of the triangle that we've just found multiplied by the length. Okay? So for this shape here, we need to find our area of our triangle. Now, whilst it's not written in, that's a right angle. So that means that this is my base and this is my height. So my area of my triangle would be 5 multiplied by 8 divided by 2. And then we would multiply that measurement by the distance between those faces, which in this case is 12. And you should be calculating these things as you go. So we've got 5 multiplied by 8 is 40, divided by 2 is 20. 20 multiplied by 12 is 240. Once again, centimeters cubed for the units. So, as I've said here, the height is the perpendicular height, so you've got to be careful that the bits that you're measuring, or the measurements that they're giving you, are the ones that you need. Cylinders. Cylinders are another kind of prism that we have to look at. Cylinders, hopefully you are aware, they're circles at the ends. Okay, we've learnt all about the areas of circles. The area of the circle is pi r squared. So for a general cylinder, so if we had this as our cylinder, this would be the radius, and then we would have a height h. So it would be pi r squared multiplied by h. Now they say h because it often stands on its end, but obviously if it was on its side, then this would be the value of h. Okay, so looking at this particular cylinder, we know our formula has pi r squared, but look here, this measurement is the diameter. So we have to first of all find the radius. So the radius of this circle would be half of it, so that would be 11 centimeters. So our radius would be 11, so that means our volume is going to be pi multiplied by 11 squared multiplied by 18. So pi r squared multiplied by 18. And I don't know the answer to that, 1 second. Okay, that gives us 6,842.39. Okay, and that would be centimeters cubed again. Okay, so other solids may be given to you. So you may not have a solid that's a cylinder or a triangular prism, cube or cuboid. But if they do ask you to find the volume of anything else, then they will give you these special formulae. Now, we know that what these things mean. So we just need to literally establish our value of either A and H and plug them into our calculator. They're next to each other, so they're being multiplied. R is being squared, so we need to make sure we use our square button, and here it's cubed. So here are formula that you don't have to learn them, but you may be asked to use them. Okay, right, to find the volume of the following. So this first one is a cuboid, so we are going to multiply those numbers together. So we've got 17 multiplied by 16 multiplied by 29. So 17 multiplied by 16 multiplied by 29 gives us 7,888 meters cubed. So notice this one's meters. Right, this is a triangular prism, so we need to find the area of this end face here. So that would be 9 multiplied by 6 divided by 2. And then the distance between those faces is this value here. So that would be the 10 that we then need to multiply by. So we've got 9 multiplied by 6 divided by 2. And then we're multiplying that by 10. Gives us 270. And this one happens to be in kilometers. So that's kilometers cubed. Here's a cylinder, so we're using that formula for the cylinder. So that's pi multiplied by 8 squared. They've given us the radius, so that's handy. Multiplied by 7. So pi multiplied by 8 squared multiplied by 7 gives us 1407.3, and again that's kilometers cubed. Okay, this one's a pyramid, so we're going to use one of these formulas that we've just been given. So a pyramid, base area A. So let's copy this so we can establish So A is the area of the base. So we need to find the area of the base first. So that would be 11 multiplied by 11, because it's a square. So that's the area of my base. I've got to multiply that by 1/3 and multiply that by the height, which in this case is 12. So I'm just following my formula. 1/3 multiplied by 11 squared multiplied by 12. And remember, you can put in fractions in your calculator. We've learned how to do that. Unfortunately, I can't show you. So 1/3 multiplied by 11 multiplied by 11 multiplied by 12. So that gives us 484. And that's centimeters cubed. Okay, this one's a sphere. Go back to our formula sheet. So a sphere. So let's snip it. Four-thirds pi r cubed. So r, we know the value of r is 7. So the volume is 4/3 multiplied by pi multiplied by 7. Oops. 7 cubed. Okay, so we've got to be careful here that we make sure we remember to cube it, not square it. So that's pi, no, 4/3, sorry. 4/3 multiplied by pi multiplied by 7 to the power 3. So that's 1436.76 centimeters cubed. Right, I think I've done enough examples with you that you can now have a go at the rest. So if you can pause the video. Oh, here's a cone. Let me do this one on the next page. So a cone. So we need to go back to our formulas. So here's a cone. So this is this formula here. So this would be 1/3 pi r squared h. So r in this case will be the 2, because that's the radius of the circle, and h would be 7. So that's 1/3 multiplied by pi multiplied by 2 squared multiplied by 7. Okay, so obviously the writing's not that clear, but hopefully you can hear the words so you know what to write. So 1/3 multiplied by pi multiplied by 2 squared multiplied by 7. So that gives us 29.3. Oh gosh, that was a mess. 29.3215 miles cubed. That's an unusual unit. Now for this this one here, you can see it is half a sphere, a hemisphere. So we would follow the formula for the sphere, and then hopefully you're saying to yourself, divide by 2. So we would follow this formula for the sphere. Okay, so that's your formula for your sphere. But then we would divide our answer by 2 because it was a hemisphere. Right, so let's not bother with this one. So you can leave that one. Do those ones. Right, so if you can pause the video for now, and then you can come back and fill in the answers to the questions that I've left for you to have a go at yourself. Okay, so here are some answers here. Be careful with this one. Make sure that you use the radius, not the diameter. Okay. And this page, as I said, you had to divide that one by 2. Didn't do this one. Again, you had to make sure you use the radius of 9, not 18. And here the radius had to be 21. Okay, so there's those answers. Check them. That would be good. If you didn't get the right answer, please find someone in the class that may be able to help you if you're not sure where you went wrong. Okay, hopefully I didn't go wrong. So here we come to more complicated volumes, but essentially the reasoning is the same. So we find the area of this end face and then multiply by the distance between the faces. Now the difference here is that this particular shape is not, this particular face is not a shape. It's actually made up with 2 different shapes. So what we're going to do is we're going to find the area of the 2 parts separately, add them together, and then multiply by the distance between the faces. Okay, so if I were to find the area of this black shape here, we know that it is a rectangle, and I can see that my measurements are 7 centimeters multiplied by 2 centimeters. So that area there, the black area, would be 7 multiplied by 2, which is 14. Okay, the red area here, I know that this measurement here is 6, and this measurement here is the same as this one, so that makes that 4. So that area would be 6 multiplied by 4, 24, which makes a total area there of 38 centimeters squared. Now the distance between the faces is 6 all the way along, and so now what we're going to do is 38 multiplied by 6. So that is 228. So the volume here is 228 centimeters cubed. Okay? Right, this one here, it's got a block, it's got a hole in it. Okay, so a hole means that we've got stuff missing. So to find the area of this end face again, we would need to find the area of the big square, it's a square, and the area of the small square, and subtract the small one from the big. So the area of the big square would be 5 multiplied by 5. The area of the small square is 2 multiplied by 2. As I said, this time we're subtracting. So the area of our end face this time is 21 centimeters squared. The distance between those 2 faces is 8. So the volume is 21 multiplied by 8. Which is 168 centimeters cubed. Here we go. The diagram shows a cuboid, the area of the end face. So here they've told us this area of the end face. Okay? They've told us that this is 8 centimeters squared. These questions have told us the answer. They've told us the volume. So if I call this measurement H, that means that for this question, that 8 multiplied by H would be 80. So what we're doing is we're setting ourselves up an equation. They've said that the area of the end face is 8. We don't know this measurement, but they've told us that the volume is 80. So that math means that for this particular question, the value of H was 10, because 80 divided by 8 is 10. For this one, same end face, but changing this length here though, because the volume is now 96. So we're saying that 8 multiplied by H is 96. So to find H in this question, we would do 96 divided by 8, which is 12. And these would all be centimeters. And for this one, we've got 8 multiplied by h equals 20. So h is 20 divided by 8, which is 2.5 centimeters. Okay. This one here, again, it's a similar kind of problem in that they've told us the actual volume of it, and they've asked us to find something missing. So these are those harder questions. So we say to ourselves, how would we find the volume of it? We would find the volume by finding the area of this end face, which is a triangle. So that would be 2 multiplied by h divided by 2. And we would then multiply that by the distance between the faces, which is 6. And they've given us the value of 42. So we've set ourselves an equation. Now this is nice here because look, we've got 2 multiplied by h divided by 2. So what happens is that these 2's actually cancel each other out. So we've got that 6h multiplied by 6 gives us 42, which means that h has to be 7 centimeters. Okay. Now, I know nets is on here. I'm actually going to leave that for now, and if when I get back we want to look at them, we will. But I left it on here just so you can have a look. Net just means the opening out of a solid shape. So if this was your solid, we could open it out to be this, and it enables us to find what we call the surface area.